Hi everyone, thanks for joining. Today our topic is garbage collection in Java. But before going to that, let's begin with a quick reminder of memory management in different programming languages. What's it about? Obviously that each entity used in code like variable, array, etc. requires some memory to be allocated for it. But after it's not needed anymore, allocated memory should be released. Otherwise, it will end up really soon. We have different types of memory management in various languages. But in short, we can say that some languages use automatic memory management, usually with some kind of garbage collectors, and others need to be controlled manually. When in program, code memory should be allocated and deallocated for each entity. As you may know, in Java, when you're programming something, you don't have to manually allocate and deallocate memory for all variables and objects that your program creates and use during runtime. This is because Java uses an automatic memory management system called a garbage collector that is a part of JVM where all program runs. Let's begin with the definition of garbage. In short, garbage is considered objects that are not reachable from garbage collector routes. GC garbage collector identifies all leaf objects by traversing the object graph. In addition, objects visited and marked as alive won't be garbage collected. To be able to traverse the graph, starting points are necessary. Thus, GC routes are starting points for tracing collectors. So what are they? Routes, let's discuss. The first one is so-called system, aka application class loader. When the Java program starts, compiled classes are loaded by the class loaders. Your classes are usually loaded by the application class loader. There can be custom class loaders, which are also can be considered routes, but unlike system class loader, they can be garbage collected. And then all the routes are gone. So classes loaded by application class loaders and their static variables are routes. Active Java threads. The active threads, local variables and thread stacks. The object that has a reference in the thread stack is defined as reachable and not considered for garbage collection. Regularly, this is the place where your program produces the objects that will be garbage collected in the future when threads complete their work and stack is drained and there are no leave links to early created objects. There are also exist other different type of routes like JNI, Java native interfaces, when you can call foreign functions from from libraries in C, for example. But it can vary. There is no documentation per JVM about which specific objects are GC routes for them. But thread, active threads, thread stack, class loader is always routes. Let's head to garbage collection itself. No matter what implementation of garbage collector we use to clean up the memory, short pauses needs to happen. Those pauses are also called stop the world events, or STW in short. The first step of the cycle starts when your JVM threads are started and your business code is working. This is where your application code is running. At a certain point in time, an event happens that triggered garbage collection. To clear the memory, application threads have to be stopped. This is where the work of your application stops and the next step starts. The garbage collector marks objects that are no longer used and reclaim the memory. Finally, an optional step of heap resizing may happen if possible. Then the circle starts again. Application threads are started. The full cycle of garbage collection is called epoch. The key when running GVM application and tuning the garbage collection is to keep the application threads running for as long as possible. That means that the pauses caused by the garbage collector should be minimal. Serial garbage collector is the simplest GetSay implementation, as it basically works with a single thread. As a result, this GetSay implementation freezes all application threads when it runs. Therefore, it's not considered good for multi-threaded applications like server environments. Next, parallel GetSay. Unlike serial garbage collector, it uses multiple threads for managing heap space, but it also freezes other application threads while performing cleaning. If we use this garbage collector, we can specify maximum garbage collection threads and pause time, throughput, and footprint. Next is concurrent mark sweep implementation. Its implementation uses multiple garbage collector threads for garbage collection. It's designed for applications that prefer shorter garbage collection pauses and can afford to share processor resources with the garbage collector while the application is running. Simply put, applications using this type of GC respond slower on average, but don't stop responding to perform garbage collection. But this garbage collector is considered as deprecated and should be replaced with G1 GT. The second thing that we need to talk about is generation. Java garbage collectors are generational, which means that they work under certain principles. Young data will not survive long. Data that is old will continue to persist in memory. That's why GVM heap memory is divided into generations. Hidden space is divided into two sections called hidden space and server space. All generation or old generation or tenured space. However, the G1 garbage collector goes a step further and divides the heap into something called regions. A region is a small independent heap that can be dynamically set to be of hidden, survivor, or tenured type. Such architecture allow for different operations. First of all, because the generations are divided, they can be collected in portions that affect latency, making the garbage collector faster for such heaps can be easily defragmented and dynamically resized, but it have its cost. The cost of maintaining such heap is higher compared to traditional heap architecture, higher CPU requirements and memory. When performing garbage collections, G1 shows he starts with a concurrent global marking phase, where it determines the liveness of objects through the heap. And after this concurrent mark phase, G1 knows which regions are mostly garbage. It collects in this area first, which is usually yields a significant amount of free space. And the second phase is called sweeping or evacuation. So yeah, garbage G1 GC firstly clean up the most garbage regions, and that's why it's called garbage first. G1 is designed for application running on multi-processor, multi-threaded machines with a large memory space. It's available from JDK 7, update 4, and in later releases. And G1 collector should replace CMS collector since it's more efficient. To enable G1, we can use following argument. Okay, let's do some small demo. Let's compare several garbage collectors. We will run the same application, but with different key, with different configuration of garbage collector. This is simple demo application that's do nothing, just producing a lot of objects that should be garbage collected. And to take a closer look, we will use Visual VM with Visual GTC plugin. I'll tell about such tools a bit later. Okay, so this is G1, this is parallel, this is serial. Okay. So as you see, while our application running, is create a lot of garbage objects, and in a heap monitoring graph, we may see such spikes. Usually they show that everything is okay, that our garbage collector is capable to work without problems, to clean up the heap while it's required. Now let's try to compare. Let's try to compare, maybe find something different. So for the first, you may notice that G1 garbage collector uses a bit more, occupies a bit more heap. It starts cleaning when heap is loaded almost in half, and the serial is cleaning earlier. What else? Between the parallel and serial, we may notice difference in survivor regions. So you may see that in serial, survivor region looks the same, pretty the same. And in parallel, they are not, they're changing. This is because how parallel garbage collector works. It's use multiple threads and it not synchronize between them. It's not, so each thread has its own part of heap to manage. And that's why sometimes with parallel garbage collector, heap will be more defragmented, more less. Yeah, it will be more defragmented. What else can we notice? For the G1 garbage collector, we do not see objects in survivor 0 region because it don't have such regions. It have only three region types: Eden, survivor, and tenured or old. Yeah, but we rarely will see old generation in this demo because all our objects is garbage from the beginning, and they will be collected soon. Okay, let's stop with this demo for a while. And continue. Automated garbage collection is good, but it's not bulletproof. Let us talk how can we make life harder for us and for garbage collectors. It is possible to throw away the advantages that automation memory management gives to us. For example, if we have problems with growing heap during runtime and we do not want to find out the reason, we may try to use system.gc. It's a function that can be called inside your application. This function triggers GM garbage collector to start garbage collection, to start the process, and hope that problems evaporates, but it's usually not. And this is not a durable solution to resolve memory usage problems. If so, do not consider to call system.gc as a solution to resolve problems with your current garbage collecting process. If your heap is too occupied, if you don't have not enough memory, this is not the solution. Method finalize. It could be easily used to make your GC work harder. Whenever class finalize method is overridden, then objects of that class aren't instantly garbage collected. Instead, the GC queues them for finalization, which do not allow them to collect them immediately. So, and let's take a look at the example of really bad finalizer. I have such class with overridden finalizer, and it's do nothing. It's just make thread wait, which makes garbage collection of it really hard. So I'm doing nothing special, just creating them constantly. Let's take a look once again in Visual VM. We remember that spikes in heap means that everything is good, that garbage collector able to clean up our heap without problems. But as you may notice, it can't do it right now. The heap keeps piles up because garbage collector sees that those classes have overridden finalizers. He in those method, let's imagine that there is a lot of work, and he just don't manage to collect this object while he collecting garbage because he don't have much time to collect garbage. It don't have much time to collect the garbage. So yeah, we completely kill our garbage collection almost. What else? Static variables. As I said earlier, static variables are GC roots. And so yeah, you may see I have a static array list, and I want to fill it with a lot of objects to make garbage collection impossible. Let's take another look. Demo static. And yeah, keeps growing. Usually it's not so obvious like in example, but always remember that not consider static variables as some kind of object holder. It easy way to go to out of memory errors. It easy way to paralyze your garbage collector work. What else? Unclosed resources. Whenever we make a new connection or open a stream, DGM allocates memory for these resources. It's, for example, database connections, input stream, session objects. Forgetting to close those resources can block the memory, thus keeping them out of the reach of the garbage collector. This can even happen in case of an exception that prevents the program execute from reaching the statement that's handling the code to close the resources. What else? Inner class that reference outer classes. I have the demo for it too. Inner class. So we have some kind of outer class with int arrays, and it have inner classes. Let's create a bunch of inner classes, keep them in static array, and let's see what will happen. So yeah, static variables are roots, but that's okay. I just want to show you. One moment. Our heap will grow, and if we take a closer look to our memory, we will find that it's filled with integer arrays. Because each instance of inner class keeps linked to its parent class, to its outer class. So for example, if you have outer class that holds a lot of data, yeah, and you for some reason need to create a lot of instances of inner class that may be some kind of utility or something like else, it's a bad idea, because each instance of inner class will hold reference for the outer class, not allowing to garbage collected. As you see, our inner class is basically empty object. It's not containing anything, but our memory is flooded with integer arrays. And because we keep inner classes in static variable, yeah, we pile them up in static array. Each inner class still holds the reference to its outer class. Okay, let's proceed. And improper equals and hashcode implementation. It also can harm your garbage collector. When defining new classes, very common oversight is not writing proper overridden methods for the equals and hashcode. But hashset and hashmap use these methods in many operations, and if they are not overridden correctly, they can become a source for potential memory leaks problems. Like an example, Hibernate. It's a framework that helps you work with databases, and it heavily relies on equals and hashcode methods for entities used by Hibernate. So if you do not overwrite equals and hashcode, Hibernate can pile up them in cache, thinking that all those entities unique. And this could cause a memory leak in your application. To continue the topic of what could go wrong with your garbage collector, I'd like to describe a few ways to monitor and diagnose problems. Usually, if such problem occurs, it could be hard to find the reason. It will be not like in the examples that we saw earlier. You will have to diagnose your garbage collector, heap, etc. But luckily, there are tools to help you out in such situation. First of all, you may use additional GVM options to enable garbage collection logs. Let me show you an example. So here I have these options. Oh, yeah. Yeah. And we see that now we can see the logs. The reason of new collection started, the time that required for garbage collection, etc., etc. And maybe one of most used, I guess, it's a heap dump on out of memory error. This option is used when your application constantly runs into out of memory errors. It provides you dump of the heap, and with this dump, you may figure out what's the reason why you run out of memory. Then JStat, it's a command line tool that are built in some GTKs, but not all of them. It depends. Let me show you an example how to work with JStat. Yes, I will just choose randomly some of running Java applications. Demo normal. Okay. So yeah, it's also provide info about regions, about pauses, etc., etc. Then we may use some tools with a user interface, which usually helps to understand provided statistic of your GVM, heap, and garbage collection process. but it could be a bit harder to monitor applications that running on some kind of remote server. You will have to additionally open ports on a remote server, provide configuration for JVM, etc. Yeah, by myself, I prefer Visual VM plus Visual GC as plugin, as you may saw. Okay. We've been talking about issues related to memory leaks in Java and about monitoring tools that could help us to resolve them. But actually, I hope it's quite rare to resolve such problems related to garbage collection, related to memory leaks. Usually, engineers need to do something with GC is tuning. It could be related to specific program that you're currently working on with. It could be related to specific requirements, like you really need to make stop the world pauses as short as possible. Or you found out that for some generation, you need to add extra space in a heap, like you have a lot of old objects that created during runtime, but they are stable and they're not changing after they reach the threshold. And to reduce the load on garbage collector, you may increase such space for all objects. Yeah. So after you decide that you need to adjust some settings for GC, you will start by looking at how your application behaves, what events fill up the memory space, and what space is filled. Remember that assigned objects in the hidden space generation are moved to survivor space. Assigned objects in survivor space move to tenure generation if they survive enough garbage collections. And assigned object in tenure generation usually ignored. They quite rarely to be collected. You need to be sure that you understand what is happening inside your application heap, and keep in mind what causes the garbage collection and events. That will help you understand your application's memory needs and how to improve garbage collections. There are various ways to tune garbage collectors. Usually everyone starts with a simple tuning like heap adjustment, because it often helps without the need for further investigation. And initial heap size often can be not configured to fit its current environment. Then there are options to choose the garbage collector that will be used, and depending on that choose, a lot of additional adjustments. You can control generations, thresholds, number of threads that will be used by garbage collectors, etc., etc. I'm not going to describe them all because they all may differ for the garbage collectors and what problems need to be solved. So just keep in mind that garbage collectors are really highly tunable tool. And in the end, what I'd like to say, luckily in Java, we don't have to think about each memory allocation and deallocation, but that's not mean that we should completely ignore this. Good engineer should understand how it works, because I believe it's not often problems. So you don't need to write yourself garbage collector by yourself, yes, but you need to understand what could cause the problems, how they can be fixed, how they can be allocated, how they can be monitored. So yeah, all this knowledge is necessary for engineer. And that's all from my side. Thank you for attention.
Thank you, Rustam. Let's move on to our questions. Yeah, and first question would be, how much should a junior know about garbage collectors? What do you think?
I believe it's not often question for interviews. Like I didn't met. I don't have experience that someone in interview asked me or I asked someone about garbage collections, but it's still it could be asked. I don't think that you need to like how to say it. You don't need to.
May I help with this question?
Yeah. Sure. Thanks.
I would say that you should understand the general concepts. What is garbage collector, and well, understand the very basics of garbage collection process. You definitely don't have to remember all these algorithms and how they're different and all these options to configure GC algorithms.
Yeah. Thanks, Daniel. That's a good answer.
Thank you. I hope that answers the question. And next question is, when is it necessary to tune the garbage collector?
It depends. It depends. It depends what problem need to be solved. Like I said previously, you may meet requirements that make stop the world pauses as short as possible. So it is possible to tune garbage collectors for that. So make more work in concurrent with your application. Or it can be situation when you need to, it could be something easy, like you need just to adjust heap space, initial heap space, like because of the environment. So sometimes, and it depends on the task. It depends on requirements. But it's not everyday activity, like after drinking coffee, today we're going to tune garbage collector.
Yeah, thank you. Yeah, the following question is how to choose GC algorithm for program?
It's again based on the requirements for your program, but usually for server application, for multi-threaded environments, everyone choose G1, maybe parallel garbage collector. And serial garbage collector is used for some kind, maybe small apps that running on single threaded machine. So yeah. It depends on requirements. If you have big server application that have a lot of that require a lot of memory. So, for example, with a really huge amount of not huge, with a really huge amount of memory could work only G1. So yeah, if you need like 20, I don't remember exact number. So for example, if you need 20 gigabytes of memory during runtime, there is no other options as G1. So yeah, it depends on requirements.
Sorry, may I add here? Regarding garbage collector, as far as I remember, G1 is the default option starting from Java 8, and CMS is already deprecated. So we can say that choice is made instead of us, and by default, G1 is good in Java 8 and further versions.
Yeah, thanks, Dmitry. I agree with him. Usually there is no such question like what should we choose, but sometimes it could be like if you need to run small application on some toaster, for example, or microwave, then you should choose serial garbage collector.
Okay, thank you. The next question is, in which cases it is reasonable to override finalize method?
It's never reasonable. It's not. There is no such cases to where it could be reasonable. It's considered really bad practice. Finalizers are deprecated in new Javas, so don't think about it. There is ways to close this. So, like for example, if it's often situation when you need to finish some work, yeah, to do something before the object will be destroyed, to close resources, to write some logs, but there are better tools for that, like closable interfaces, closable, auto-closable interfaces, etc. And they will not affect garbage collector. They will not make it work harder.
Yeah, thank you. And one more question. Do we need to remember all these GVM options?
No, I believe
And
not.
maybe the question where we can find them.
You can Google it. Options may vary. It depends what GVM do you use. So I believe it depends on the GVM, and these options provided in Oracle documents, I believe, for hotspot VM. So you just need to remember that you have options for tuning garbage collectors, like, and at least something that you can adjust heap, you can change the thresholds, you can change the occupation %. So when you run in some new requirements related to the memory in your application, then you will remember that such options exist and easily find it. So yeah.
Okay, thank you. And maybe the last question, if no one else post anything. Could you tell about GC partition? Then survive 0, 1.
Sure. I'm not sure what the question about. So like all new objects goes to Eden space. So it's where they start. Then garbage collection happenings, 1 second, and object that survive first collection goes to survivor space 0. Then depends on, I don't remember exactly numbers, so, but there are counters, like this object survive 5 cleanings, then she should be moved to another space. Then this object survive 10 cleanings, then she should be considered as tenured or old space. So yeah, it's this generation based on principle that if some object live long, that it rarely should be garbage collected. Like if object lives short time, he will go into Eden space, and soon after, when he not needed, he will be he will be cleaned. So in Eden space, cleanings goes more often than in other regions, because it's most. This is the region where the short-lived objects persist. Yeah, and then and with the time, with the new garbage collections, old objects move it to the newer space, and they consider it as long living, and garbage collector do not waste the time to clean these objects. Yeah. I hope this answers.
Yeah, I hope to. If not, please post something in the chat, maybe additional question to that. So I don't see any questions for now. Yeah, I think we can end our meeting. So thank you everyone for joining, and thank you, Rustam, for your presentation.
Thanks for help. And thanks for joining.
Yeah, thank you everyone, and goodbye. Have a good day.
Goodbye.